Hi, here's a run through of some practice problems for your quiz tomorrow. Here we go. Call it a practice quiz if you want. Sodium fluoride decomposes. There's a mix here of like words and symbols. So we'll start with this word problem number one. Sodium fluoride decomposes. So if you're looking at words, you got to write the words first. So you got to figure out what is sodium, which is +1, what is fluorine, which is -1. So the formula is NaF, and it decomposes. That means that's the only reactant, and it's going to break apart into its pieces, sodium and fluorine. However, fluorine is a sneaky 7, so you're going to want to, when you balance it, you're going to want to put a 2 here because it's a sneaky 7. And then when you balance it, you're going to put a 2 here and a 2 there. Sodium fluoride decomposes. Next one is a double replacement reaction. You've got strontium nitrate, SrNO3, 2, and nickel sulfate. And you're going to crisscross them. Sorry, the outside ones are going to go together. The inside ones are going to go together, and you're going to crisscross them when you put them together. So you need the charges for each of them. So in the first one, strontium is going to go with sulfate. Strontium is a +2. I'm going to write down here. Sulfate's a -2, so they cancel out. So Sr, SO4. Then you have nickel and nitrate. Nickel is, well, you got to figure out what it is. So look, sulfate is -2. So to cancel that out, nickel must be +2. So it's going to stay +2, and it's going to pair with nitrate. So nickel is +2, nitrate is -1. And when you crisscross them, you're going to get NiNO3, 2 when you crisscross them. And this one's all balanced. So if you go with that route, we're going to erase these guys here, and our double replacement reaction, strontium nitrate reacts with nickel sulfate to make strontium sulfate and nickel nitrate. Next one, potassium is dropped into a solution of zinc carbonate. So potassium is just a single metal by itself, potassium like that. Zinc carbonate, oh, that's fun. Zinc is +2 and carbonate's -2. So you have ZnCO3 because they cancel each other out. And then potassium is going to kick zinc out. Zinc's going to be by itself, and it's going to pair up with carbonate. So potassium is +1, and carbonate is still -2. So when you crisscross them, you get K2CO3. And then now zinc is going to be alone, just like that. Zinc's not a sneaky 7, so it does not need to have a 2 or anything by it. And then to balance it, you're going to put a 2 just in front of that potassium, it looks like. So that's easy stuff. Put a 2 right there, and it's all balanced out. Next one, words again, rubidium and sulfur. Rubidium is that, sulfur is this. This is a synthesis reaction. They're both, neither of them are sneaky 7, so they can both be alone. Rubidium is +1 and sulfur is -2. So when you crisscross them, you get Rb2s. And to balance that, again, you're just going to need a single 2 on that rubidium. Next one, we've got a combustion reaction. You can see it says combusted right in there. It's C6H11OH. Just to make it complicated, but the H really can be paired with the other H. So there's 12 H's there. Combusted oxygen means it reacts with oxygen. Any combustion reaction is the same, CO2 plus H2O. And now it is time to balance it, which might be tricky. Looks like it's complicated. So 6 carbons, and then hydrogens, they're just broken up here. So bear that in mind. So there's 12 on the left-hand side. So I'm going to put a 6 here. And that gives me 6 times 2 plus 6 is 18 oxygens. You already have 1 here, right? So you really just need 17 here. And 17 divided by 2 is, what's that, 8.5? So you put it 8.5, but really you're just going to double all of them to get rid of that problem of having 8.5. So instead of 1, 8.5, and 6 and 6, we're going to go with 2, 17, 12, and 12. Same ratio, but now it's all lowest whole number coefficients. And that is a combustion reaction. Finally, the maybe hardest kind of problem is one where you have to, it's words and it's double replacement, so you got to crisscross 4 times. So titanium 2 nitride is going to be, I might as well write these out. Titanium is +2, nitride is -3. And aluminum is +3, and phosphate is -3. This is your A, B, C, and D if we're keeping track. So titanium 2 nitride, Ti3N2, and aluminum phosphate, they just cancel out AlPO4. Now the A and the D go together. A and D go together, and then, of course, the B and the C, actually the C goes first. C and B go together. So on the other side, we've got titanium, which is +2, and phosphate, which is -3, so Ti3PO4, 2. And then aluminum and nitride just cancel out AlN, +3 and -3. Then when you want to write the formula, or sorry, when you balance it, you're going to put a 2 here for aluminum, 2 here for aluminum, 2 nitrogen, 1 phosphate, 2 phosphates, 2 phosphates, and then that's it. Titanium's all set. So in the end, there is your correctly balanced equation for a double replacement reaction with words. There's a quick rundown of 6 column practice quiz problems that you're working on in class. Okay, this has been super fun. We'll see everyone soon. Hugs and kisses. Bye.